Hello, greetings to all. Today we will cover exception handling in C++ in depth. We will learn what exceptions are, why we need them, how to use try, throw, and catch, how multi-level exceptions propagation works, and why C++ uses RAII instead of finally, and how to design user-defined exceptions. And we will also examine multiple code examples in detail for all the categories here. First, why do you need exceptions? Let's take a small code to understand the need for exceptions. Include IO stream. You know that it includes input-output functions like cin and cout. And by using namespace, let us use standard names without using standard colon. The program starts executing the main function. Two integers a and b are declared to store user input. Cout displays the message, enter two numbers. And cin is going to get a and b. We're going to read two numbers from the users, that is a and b, the value for a and b. And if checks if b is equal to 0, then if it is true, it prints the error message, that is error division by 0. Why? To avoid a crash there. Otherwise, it performs the integer division and prints the results. The program ends after displaying the output. That's what a simple code here. Now, what will happen when you are not giving if b equal to 0? So the main work of that is to check whether b is equal to 0. And if it is equal to 0, it is just printing an error message. So this acts like a guard to avoid dividing by 0. Yes. And let us take few example use cases here. Let us take user type sort 10 and 2. Input is 10 and 2. Then it goes by a normal division. So the output result is 5. And when we take inputs 7 and 2, it goes for integer division. So the output, again, the result is 3. Here, the decimal part is discarded because we have given int. Next, the third case, let us take input 5, 0. The divisor is 0. So naturally, the output will be division by 0. In the last case, when we take some letters, A and B letters as inputs, the cin will fail since it expects only the number. So when the cin fails, variables A and B remain uninitialized. This may lead to unpredictable output or garbage values. So this is not allowed, and therefore a good program always checks and validates the user inputs. So the common pitfalls in C++ programming, let's see very in detail the 5 different categories here. First, talk about integer division. In C++, dividing integers always gives an integer result. And here the fractional part is distruncated, okay, or it's removed or distruncated. Example 5 divided by 2, answer is 2 and it's not 2.5. So, but when we want 2.5, to get the decimal results, at least one operand must be a floating number, floating point type. That is, can do either float or double, so that your output is 2.5. So this is the first category under that. Next, coming to the bad input. If the user types an invalid input, example, a letter when an integer is expected, cin automatically goes to the fail state. So when this happens, the input extraction stops. You need to check and clear the error before continuing. This is a small example given here, right? So how could you prevent this? If I'm using if cin or if not equal to cn, which means that if cn fails, then automatically you can give the print invalid input. Therefore, this clears and ignores the bad input before reading it again. Yes. And next, coming to the third category, division by zero. We already have defined that in the program itself by assigning a b double equal to 0. So it avoids undefined behavior. It always validates devices. Coming to the fourth category, that is signed overflow. And if the numbers are huge, certainly there's a chance for integer overflow. For example, let us take that we are going to store 200 crore, that is 2 million, and we are going to multiply by 2, and we are going to store it in a 32-bit int. So naturally it overflows. C++ does not guarantee behavior for signed overflow. So it's undefined there. So to avoid this, we have to use larger data types. That is like long, and unsigned long, okay? Or check ranges before performing arithmetic. So this could be the way to avoid it. Coming to the last category, that is using namespace standard. Writing using namespace STD is common in examples, but it's really risky when you work with real world projects because it imports everything from the standard namespace, which may cause naming conflicts. So the better and safe approach is, yeah, use standard double colon count when you're using it for a real-time applications. So in summary, I could say that integer math giving unexpected results, input handling errors will be there, and division by zero, it will crash. Integer overflow in big calculations will also leads to crash. Namespace population in a larger projects. So we have to keep all these in mind before doing a very good programming. So that's why there is a big need for the keyword exception. And exception is a runtime event, and it's like an object or a value which is raised by a program when it encounters an unexpected or erroneous happens, causing normal execution to be interrupted or disturbed so that the control can be transferred to a special error handling routine. An event that signals a problem. Exception is an event that signals a problem. An exception represents an unusual condition detected while the program runs. Example, divide by 0 and file not found, something like out of memory, invalid user inputs, etc. It's not just a printed message. It's a signal your code should react to. In C++, when something goes wrong, example, dividing by 0 or opening a missing file, your program can throw an exception, basically sending out a signal that something unusual has happened. That signal is sent in the form of a value or an object. That's why initially I said exception is a runtime event, an object or a value. Yes. And in C++, you can throw values in ints and strings, or preferably objects, usually types derived from standard exception. Thrown objects, we'll see in the code in the further coming slides. Thrown objects carries information about the problem, for example, via the what method. We will see in detail when we're talking about the program here. Why we use exceptions, now you're very clear, because we need to remove divide by 0, file not found, and invalid output. So traditionally error handling uses if statements everywhere. But what will be the problem when you use if statement is it clusters the logic and makes debugging very harder. It's not that we are not saying to use if, but if you're using if for these purposes, then it becomes a cluster the logic and makes debugging the harder. So whereas exceptions separate normal flow from the error flow. Therefore, they avoid clustering. They clustering the main logic with the repetitive checks, and it allows centralized responses to the problem. This is the plus point of using the exceptions. Students note it. So for the same example here, there's a safer version of the code and which validates the input, which uses double for decimal results and asks again on input valid or not. Like, see here, if you could see that we have used double instead of int, we have used double here, and we have used whether whether they are getting a proper input, whether that's not equal to cin, then just display the error message. And we have also checked for division by zero, divide by zero, and it's giving the result. A small thing, this all we call as small level exceptions, so that your program runs without much delay. Next, coming to the three main basic keywords that you need to handle the C++ exceptions. They are try, throw, and catch. This is the order of the sequence. First try, then throw, then finally with catch. So I will tell you with an analogy so that you understand this much clearly. Let us take an ATM analogy for exception handling. The normal flow is you insert your code, ATM code, enter your PIN, you request the cash, and everything works fine. Everything works fine. So this is example for this is like a normal execution of the code inside the try block. This is something like that. Coming to some exceptional situations, and that I'm calling it as a throw. That is, something unusual is happening. A code is blocked, or insufficient funds there, or network or server error is there. So the ATM cannot continue the normal process. So it is raising an exception, whatever the throw is doing here. For example, here that my throw is there. Okay, so that it will be raising an exception, and next handling the problem. So for that you have a catch block. So ATM does not crash or break. Instead, it shows a message like your card is blocked and please contact the bank. Otherwise, something like insufficient balance. So this is the catch block where the program handles the error very gracefully, so that the ATM machines will not itself be a fault, so that the people who are standing in the queue are not being affected. So it's like continuing the service. So after showing the error, the ATM may return your card and allow the next customer to use it. Similarly, in C++, a catch block executes. The program continues after the try catch instead of just crashing completely. Yes. So when I map this ATM analogy to a C++ terms, I could tell that try is something like a normal ATM transaction is being attempted. Throw, when something goes wrong, you give an error signal. That's something like a throw. And catch, ATM shows the error message and handles it very gracefully so that it is allowing the next its customer to use it. That's something called as a catch. Just try in that way. It is easy for you to do the code when you understand this. So that's why we are given here, try enclose a code that might throw, and throw raises an exception. And for example, we are going to use here for the example below that we are going to use constant star for that. And as an example, and next catch specifies the parameter type to match thrown exceptions. And after the catch executes, the execution continues after the try catch block. And how to raise it? By using by throw code that detects a problem uses a throw statement to raise the exception. For example, here it's given if you're not equal to file open, throw some error message, that is standard runtime error, which means the file is not found. Something, this message will be thrown. Yes. Yeah. So this ATM analogy, I think you will be able to understand this try, throw, and catch in exception handling. coming to the example, before coming to the example, let me just give you other few points in this exception, how it's handled. Now we have seen how it's handling throw we have seen here, right? Similarly, let's see how it's try and catch us being handled. The code that might fail is warped inside the try block. If an error occurs, it is thrown and then caught by a matching catch block. And here is a small code for this. We are try opening the file, it may throw. And your catch, you're giving what is the error message you are giving here. So here, if the file, that is, if open files, this fails and throws an exception, the catch block will handle it and print the error message. Okay, then what is E here? This E stands for exception. So he exception object that was thrown and caught. It represents the error that happened. Its type is always this constant std with exceptions, ampersand symbol followed by E, which means that why it's constant is we cannot modify it. It's always safe to have the same thing. So that's why it's given as constant. And why it's given ampersand here? Because we catch it by references. Why? Because we are avoiding the copying and preserves and trying to preserve the polymorphism. And standard execution, the base class of the most standard exceptions in C++. So they will have this runtime error or invalid argument, etc. So if the file open throws a standard runtime error, file not found, then E will be that object. Yes. And what is this E dot what? What? This what is a member function of a standard exception. It returns a C style string, that is, which I told you here, right? Constant care star. Yes. So that returns a C style string constant care with a description of the error. Coming to the propagation, that is a stack unwinding. Your function throws an exception, but does not catch it. Then the exception moves up the call stack looking for the matching catch. So while moving up, the local objects in each functions are destroyed automatically. This process is called as stack unwinding. I'll repeat. Let's say that a function is throwing an exception, but does not catch it. So if the expression, then that exception keeps moving up the call stack, looking for the matching catch. So while moving up, the local objects in each functions are destroyed automatically. Yes, and this is the main concept called as stack unwinding. So this is what we should thank C++ because it ensures automatic cleanup of resources. That means files, logs, and memory. And this we call by the name RAII. What is that? Is resource acquisition is initialization. I'll repeat, resource acquisition is initialization. It's a C++, what is this is? It's a C++ design principle that ensures that the resources are automatically released when they are no longer needed, usually when an object goes out of scope. For example, if a function throws while holding a file handle, the file's object destructor will close it automatically. That's called as RAII. That is the resource acquisition is initialization. It is called as RAII. That is a usually best practice is that we have to use exceptions derived from standard expression always, rather than using the raw integers and C strings. Okay. And they have examples, standard, runtime error, and all different types of error is already there in standard exceptions. Catch by constant ampersand symbol. So you have to use this to avoid slicing and unnecessary copying. So this already we have seen in the previous example. Use exceptions only for exceptional conditions and don't use it for all the normal and ordinary control flow. And using exceptions for simple if-else logic is actually bad. Instead, you go for using exceptions for error like file not found or division by 0. All these things you can use the exceptions. Coming to the guaranteed cleanup via RAII, we know that because destructors are called automatically during stack unwinding, resources are freed very safely. This plays the role of finally in languages like Java and Python. So the same function is being done by this exceptional handling here. Example, if an exception is thrown inside a function, the smart pointers, that is, example, a standard unique pointer and a standard shared pointer will still release the memory automatically. Yes. And what will happen if no catch is found? In that case, if an exception is thrown and no matching catch is found, C++ calls standard terminate. Standard terminate. Therefore, the program ends abruptly. That's why it's important to catch exceptions at least at a high level in the main part where you're writing. So for this, I could give a summary that try and catch safely handles your risky operations. If not caught, the exceptions will propagate upward, and it is called as stack unwinding. And always throw and catch standard exceptions, and you have to use the catch constant ampersand for efficiency. And so RA ensures cleanup automatically in C++, and so manual finally is not needed as if in your Java and Python. So in no catch is found, if no catch is found, automatically it terminates. Coming to an example code which is using exceptions. Let's see what is this. So this 3 is a basic thing to be noted for any program. So coming to the yes, safe div double A, comma double B we have given here, and we are given here if equal to 0.0. So the safe div checks the divisor and uses throw runtime. It is throw is here, right? And it uses throw runtime error to signal error. Runtime error is a standard exception type from the standard expectation. So in main function, the input is validated first, then call to safe div is inside the try function. On throw inside the try function, okay? So in main, input is validated first, then only call to the safe drive is inside the try function, try. So on throw, the control transfers back to the catch in main that matches the runtime error. So we have given E what here, right? We have given E what. E what gives the message passed when exceptions are constructed. So throwing here is helpful, which means that low-level functions reports error. High-level can decide what to do, whether to log or retry or ask user again and exit. So the safe div throws okay, again I have given a main comment. If it's only equal to b equal to 0, then the main catches exceptions and print a message. So yes, we went throw here. So this throw division by 0, that is when y is equal to 0 or b equal to 0, the program throws a message and skips the rest of try. The catch block executes That is thrown message is caught and displayed. Yes. So therefore, the output for this program is caught, exception, caught, exception, and that's what division by 0. So after this, the program continues after the catch. Coming to the next topic, that is multi-level exception handling. Multi-level exception handling, also called as exception propagation or stack unwinding. Just we have touched this topic previously, just a line. Multi-level exception handling means an exception thrown inside the function travels up the call stack through intermediate functions until a matching catch is found. During that travel, the runtime unwinds the stack and runs the destructors for automatic objects on the way out. So it lets low-level functions signal errors without then needing to know how to handle them. So the high-level code can decide how to respond, report, or try cleanup or abort. Automatic cleanup happens as objects go out of scope, so resources are not leaked even when the errors are occurring there. So coming to this multi-level exception handling, just with the flow diagram I have given here, let's say that your main function has F1, F2, and F3, and in the F3 we have given a throw. Okay, so if F3 throws and F2 and F1 does not catch, the control jumps back to the main or the nearest caller that has a matching catch. That's how the flow goes back. While jumping back, the local automatic objects in F3, then F2, then F1 are destroyed, which means a destructor is being run there. And this is called as stack unwinding. So I will explain you this with a code here so that you'll understand how the destructor is being done here. Yeah, let's start the main function. So the main enters, we'll talk from the main function. So in the main function, enters a try block and it executes cout. That's, it is saying that main calling F1. So and what is the output now? So it will be printing main calling F1. Okay. So next call F1 is being called. So call F1 from the main itself. So from the main, you're going to call F1. So when you call F1, F1 executes. Cout, it is saying F1 calling F2. Right? So in that, what will be the printed thing there? It will print F1 calling F2. So next, based on that, your F2 is called. F2 is called from F1 itself. So it goes to F2. So similarly, the same process happens here. So call F2 is there. Call F2, okay, from F1. So there F2 executes and it prints F2 calling F3. So now we are again call F3 from F2. So it goes to F3. So F3 executes now. So there it prints F3 about to throw. Yes. Next F3 throws an exception here. So F3 executes and it throws runtime error. That is error in F3. At this point, a standard runtime error object is created and thrown. Execution immediately leaves F3. Any statements after F3, after the throw, inside the F3 are not executed. This is the main point. So once your throw is activated and any statements after the throw inside the F3 block are not executed. So the line cout, F3, this line will never runs. This line doesn't run because it comes out, it jumps out. So stack unwinding, you could see in F2 and F1 have no catches there. There's no catch function here. There's no catch function here. the exception propagates back to the caller F2 and F2 has no catch. So it also exists immediately. Therefore, the lines all will not be executed and you do not run. Same thing happened for the F1 because it has no catch function. So this process of exiting the functions and cleaning up is called as catch unwinding. So mains catch handles the, again the next catch is in the main. So the main catch handles the exception here. So the thrown runtime error is derived from standard exception. So the catch constant standard exception ampersand E in the main matches that. So inside the catch block, the program executes. Therefore, the cout is main caught exception. This line will be executed. So E dot what returns a message passed to the exception. What is that? Error in F3. So once what will be the printed is main. In the main, caught, the output will be caught exception and error in F3. Then the program continues after the catch. Here there is no catch, so therefore the program, this all is being distracted. But here you have a catch function, so after running that catch function, it continues and it reaches the next statement, that is cout. It's telling the main program continuous. So it prints main program continuous and then the program returns 0 and exists normally. So I have given the output here, you could see. You could see this, right? So the main calling F1 and F1 is calling F2, F2 is calling F3, F3 is about to throw. And the main, the output is caught exception, error in F3, and the next line is being continued since there is a catch there. So the program continues is the final output. So this is how the order of execution of the program. Hope this is clear, right? Coming to the stack unwinding and RAII demonstration, let's use a small code here for explanation. And here we are going to use the guard structure, guard struct. By adding RAII objects, here that's guard, we can see exactly how the stack unwinding cleans up the all the locals when an exception is thrown. Let's see the control flow here step by step. And actually each guard here, what's the function of this structure is, it will be printing like something like constructed when it's created, and it will print destroy when its destructor runs. So the destructor will run automatically when the object goes out of the scope, including even during the exception stack unwinding. Assuming that these are called from the main function, main inside the try, that catches the exception, the same structures as earlier. Let's see now step by step for the main function. So let's say that the main is calling F1, right? It's calling F1. So if the main prints something before this that appears first, let's say that I think it's main calling F1 will be printed. Now it's entering F1. So in the F1 function, here we have given guard G1 runs and it prints. So here it is something like G1 is constructed. So then F1 will call F2. So when F2 is calling, here you can see that when this runs, what it will print is G2 will be constructed. Because it's calling this function, here it is G2 is constructed. So here again it calls F3. So when it's calling F3, here when this guard G3 runs, it will print, what will it print? It will print G3 is constructed. So the next line will print F3 is about to throw. Then throw runtime error, that is error in F3 will execute. An exception is thrown here and a normal execution of F3 will stop immediately. So the stack unwinding begins here. Destructors run in the reverse construction order because the exception propagates out of F3. Local objects in F3 are destroyed first. That is, G3 destructor runs, prints G3 destroyed. Then the exception propagates back to F2. So F2 has no catch again there. So it exists. Its local objects are destroyed, which means that G2 is destroyed. So the exception propagates back to F1. And if F1 has no cache, so it exists, its local concepts, objects are again destroyed, which means that G1 is destroyed. So exceptions reaches the main cache again, because here you have a catch function. So now this catch in the main, here we have given catch constants std exception ampersand e. This handles the exception. Only after all the relevant destructors have run, while the catch block execute, the catch can print the message that is the main code exception. And what is the here? There is error in F3 that will be printed. So the program is continuing again after the catch. So here you could see that the output the same order. So the destructor for G3, then G2, then G1 are executed automatically, while the exception propagated back to the main. So this is the key safety mechanism in C++. And instead of we manually using finally, as in the case of Java and Python. So hope this you understood. This is the order which I have explained from the code. Next concept of rethrowing, and which means that you are to catch then rethrow, and we'll be using for logger transform. What's here is sometimes a function may want to handle a part of exception, that is example log it, clean up resources, okay, something like that, but not completely handling it. Instead, let a higher level function deal with it. This is called a rethrow the exception. Let's see how it's being done. See step by step. F2 is calling F3, right? Suppose F3 throws an exception. Example, throw runtime error in F3, something like that. F2 will catch it. F2 catches it. The catch constant std exception ampersand e block, this block is triggered because you have a catch function here. Inside it, it prints a message F2 logged, but error in F3 will be printed here. So F2 has partially handled the exception, which means it logged it. So throw or rethrow without expressions, right? The plain throw statements rethrows the current exception. This is a throw only, but it's rethrow without an expression. It's a plain throw. The statements rethrows the current exception. It sends the same exception object up to the next higher level, that is caller of F2, example F1 or main functions. No slicing or no loss of exception type here, and the original stack trace is preserved. If the main has a catch, it can then catch the same exception again and handle it finally. Yes. So this is what preferably throw and rethrow. Rethrow, we are taking it. The statement rethrows the current exception. Though here given throw here, in this concept, in this place, it takes the role of the statement rethrowing the current exception. And the next topic which to be covered is throw versus throws. Okay, and this throw actually throws an exception used at the runtime, which we have seen till now, and throws, it only declares that a function may throw, and it's used in it's a Java feature. It's used to raise or generate an exception very explicitly, and it is used to declare that a function may throw the exceptions. Here transfers control to the nearest matching catch block. We have seen many examples with this. Informs the caller about the possible exceptions the function may throw. Appears inside a function or a try block. Appears in a function, declaration, or definition line. Example, throw error message or throw runtime error or file not found, like that. Here example, void read file throws IO exception, something it's for Java syntax. And main point is that C++ and Java both will support throw, whereas throws is supported only in Java. C++ uses no except that instead of using this the try catch and throw, in modern thing they are using no exception, or in the old throw as usual what we are doing, right? So whereas Java, it uses throws. It can throw only one exception at a time. Main point to be noted, it can declare multiple exceptions separated by commas in Java. Causes runtime exception, propagation to the calling block, does not raise an exception itself, only a declaration to the compiler and the caller. And here, no compile time checking for exceptions in C++, whereas it enforces the checked exceptions handling in Java. And caught exception, we have seen an output, division by 0, and here no output, declaration only. This is last line is an example which you have seen in the previous programs. The output will be written as caught exception, example, division by 0. Here, there is nothing like output and it's declaration only. Coming to the last topic of this exception handling using finally, using destructor concepts. C++ does not have a finally keyword like Java. Finally is a keyword that's there in Java, but it's not there in C++. But we can simulate it using destructors or RAII, which we have seen previously in the 3 programs which we have talked about. Objects automatically clean up when leaving the scope. Even when an exception occurs, the destructor runs automatically, just like a finally block in the other languages. Here is a small code for you to understand. Yes, let's enter the main function here. So the program starts executing from the main function, and you can see that there is a try block here. So in that try, you have cleanup and you have a throw function. So when the program enters a try block, it creates an object C of class cleanup. So the constructor of cleanup runs, but there's no custom constructor defined. So nothing prints it. But at this point, your C exists as a local or automatic object inside the try block. Right? And here exception is thrown. Throw, some error occurred. It's given. So a constant care star exception, it's a preferable good C style string is thrown. Immediately after the throw, the normal execution stops inside the try block. So before jumping to the cache, the stack unwinds the starts, meaning all the local objects in the try block are destroyed. Now, cleanup destructor runs, automatic cleaning up will be done. So the object C goes out of the scope because we are leaving the try block due to the exception. Its destructor cleanup is called automatically. It's automatically called. Yes. So, and it will print cleanup done. Cleanup done. So, like finally, block example. Okay. So this behavior mimics what a finally block will do in Java or Python. C++ does not have an explicit finally block. Instead, the destructors of local objects act as an automatic cleanup points. It's a very important point. I'm repeatedly telling this point. Kindly note it. Yes, the catch block. Now the catch block handles the, again coming to the catch block, it handles the exception. So after the cleanup, the control transfers to the matching catch. The catch constant character star message. It gives cout caught message end. So since the thrown object was a constant char star, this catch matches perfectly. So it prints some error occurred. It prints some error occurred with this. So this is called an exception handling using finally as if in other thing. We are not going to use the finally keyword here. Coming to the last topic here, that's user defined exceptions. And here in C++, besides using built-in exceptions like standard runtime error, standard out of range, etc., we can create our own exception classes to represent the specific error situations in the program. And what's the main purpose of this is to make code more readable and meaningful and to understand, easy to differentiate between various types of errors in domains. For example, temperature too high, invalid sensor input, etc. You can do your user-defined types. It allow customer error messages and specialized handling for your applications. So the syntax to create the own exception classes, or you should inherit from the base class standard exception. First point. Second, override the what function. This function returns a C style string, constant char star describing the error. You should throw an object of your class when the error occurs, and we should catch it using a catch block. Let's see how it's done. So here the step one, we are creating a customized exception class. Okay. So the class my exception and public exception. Yes, here the standard exception is the base class for all the standard exceptions in C++. By inheriting from it, your custom exceptions can behave like a built-in one and can be caught with either catch my exception ampersand E, catch my exception ampersand E specific, or catch standard exceptions ampersand E in a very generic form. Now step 2, coming to the override the what function. So here we have given constant char, what, constant throw, and it's going to return custom exception occurred. So this function, what, is declared in the base class, standard exception, and it returns a C style string that is constant char star describing the error. But overriding it, you provide your own error message. The constant here means the function does not modify the object. I told you already in the previous slide itself. The throw, that's a old style exception and specification here, but it indicates this function won't throw another exception. And instead of this, now in the modern C++, they are using no except instead of this throw. So whenever someone calls E dot what, they get the string custom exception occurred. So whenever they call this, they get the custom exception occurred. They get printed. Step 3, coming to the try block. So in the try, we have given a throw function here. So the throw block contains code that might throw an exception. Here, we explicitly throw an object of type myException. The moment throw myException executes, the control leaves the try block immediately. Any subsequent lines inside the try block, if any, are also skipped. The runtime looks for a matching catch block. Coming to the last, that is step 4, that's a catch block. In the catch block, myExceptions ampersand E, cout E dot what. The thrown myException is caught here by reference. my exception ampersand E. Using the reference here, that's ampersand, it avoids copying the exception object and it preserves its dynamic type. So inside the block, we are calling e.what, which returns our custom message, that is custom exception occurred. So that's being printed. Custom exception occurred is being printed. So just a recap, exception allows a very graceful error handling and separation of error logic. Yes, and C++ uses three main functions, keywords, and try, throw, and catch. And it does not have the keyword finally. Instead, it uses RAII via destructors. And it supports multi-level propagation with stack unwinding. And we can also design user-defined exceptions for domain-specific errors. Yes, hope these topics are clear with you. So coming to check your understanding about this topic, I have given 10 questions here. Please try to answer this, and finally I have given the answer so that you can cross verify your answer and check how deeply you understood the topic. Which of the following is the correct order of exception handling keywords in C++? I have given all the 4 orders. Choose the one. What is mean by multi-level exception handling? Just check and click the correct. Which of the following correctly raises an exception in C++? What happens when an exception is thrown but not caught in any function? The throws keyword is used in which programming language? Preferably. What is the use of finally block in exception handling? Which of the following statements about the user-defined exceptions is true? Just pick up the one. What is the purpose of what function in a custom exception class? In multi-level exception handling, when an exception is thrown in an inner function, it is. And here a small code is given. That's a try, throw, and catch function is given, and print is given. What will be the output? Just think about it and cross-check your answer with this. And thank you, students. Hope you listened it.